Welcome back, mathematicians. So today our lesson is on adding algebraic terms. For colors, we're going to use a pencil. I'm going to use a black erasable pen because it just shows up better on camera. And then I'm going to use a red, blue, and green as my colors. So to get started, an algebraic term is a term that has a variable. So a variable is like X, Y, Z, right? Variables are letters that stand in for numbers, and you learned that in 6th grade. So you should have seen examples of, and you don't have to write this down, but like 2x plus x equals 3x, where you're just adding the coefficients together, right? 2 plus 1 is 3, so you have 3 x's. Now what we're going to do is we're going to represent variables with bar models and show how we can combine two fractions of a variable together with a bar model that represents a brand new expression. And first we're going to represent these 4 expressions with bar models. So the expression 2/3 x. If x is just a bar, right? We don't know what it represents, but we can put x here as a bar. Okay. And we're talking about x as a fraction. So what we can do is we can split this x into 3 sections. Each of these represents 1/3 of an x, right? This whole thing represents x. And if I wanted to represent 2/3 x, I want to shade in 2 of the thirds. So that's how I would represent 2/3 x with a bar model. Now 0.5y, this is in decimal form. So when you have 0.5, that's also considered 5/10. So what we can do is we're going to draw y as a bar model, and we're going to split it into tenths. So we have 1/10, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10/10, which means that this whole thing would represent 1y, right? But as a bar model, and we're representing 0.5y, each of these is worth 0.1, so we're shading in 1, 2, 3, 4, only 5, right? So this represents here 0.5y. The same goes for an expression like 3/2 p. We're going to have a box that represents p, and we're going to split it into 2 sections. Each of these is worth 1/2, so that's 1/2 p, 2/2 p, right? Which means that this whole thing represents 1p. But you'll notice that I want to represent 3/2 p. So I need another half here. So I have to build one in. And so that's how I show that with a bar model, is this whole thing represents p. Each of these are 1/2 p. But with a bar model, I have to go a little bit further than just one box. Okay? So this is 3/2 p. And it's the same thing here with 1.2q. Okay, I'm still going to do it in tenths because we're in decimal form here. So let's do it this way. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's always good to double check. So this represents 10 tenths, which is a whole. So this is one whole Q. And I'm shading in 1.2. So I have to add in an extra 1/10 and an extra 1/10. So when I'm shading this here, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths, which is the 1, and then 1.1, 1.2. So this whole thing represents the 1.2. So that's how we represent each term individually as bar models. And what we're going to do next is we're going to take those terms and we're going to add them together in a couple different scenarios. For a second example, we are going to add 0.7x to 0.3x, okay? So I want to represent each of these with a bar model, okay? So how I represent 0.7x is really just similar to 0.5y. I'm going to have a box labeled x, or a bar, sorry, and I'm going to shade in 7/10 of that. So let's get started with that. So there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So it's easy to add decimals because decimals are always in tenths. So let's make sure I count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we want to shade in 7 of those tenths because it's 0.7. 2, 3, 4, 5, 6, and 7. So that represents 0.7x. And we are going to add 0.3x. And to represent that, again, we are going to draw a bar in tenths because that is the common denominator when we have decimals, right? These are both in tenths. If this was in hundredths, then we'd want to draw 100 squares, which would be a long process, so we don't want to do that. But here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and to close it off, 10. And to represent the 0.3x, I'm going to use green, and I'm just going to shade in 3/10. But notice they're the same variable, right? X and X, which are both in red, so that means I can combine them together. If this was a Y or trying to add like a P and a Q, I couldn't combine those together because those are two different variables. In lesson 9, you're going to see more of that. But for this being lesson 7, when we're adding terms, and then lesson 8 is when we subtract terms, we're going to be doing that with just bar models, and then we'll get to kind of combining everything together. To finish this one off though, when we add 0.7x and 0.3x, we get, again, in tenths. Right. We have the 0.7x, so there's 7/10. 1, 2, 3, 4, 5, 6, 7, and we're adding 3/10. 1, 2, 3. So when I add those together, it fills up one whole bar. Right, this whole thing represents x. It's all filled up, so this is 10/10 x, which is just 1x, and a lot of people, they just write x. Okay, so that's how we represent it with decimals. Next, we're going to do a problem where we represent it with fractions. Our next example, we are going to use the same strategy. We have 1/2 p plus 3/4 p. We're going to add those together. Right here, when we did decimals, we got 1x. And right here, we're going to use fractions and see what we get for an answer. So we're representing each of these with bar models. So we have 1/2 p, and then we have 3/4 p. Now, if you notice in the beginning, I showed you that representation of 1x plus 2x is 3x. So we're adding those coefficients together. Here, we have 1/2 p and 3/4 p. So in order to do this, I need a common denominator, okay, for my fractions, because I have to add those fractions together, and I have to split these bar models in such a way that I can combine them together. So I need the lowest common denominator. So I'm going to kind of write that on the side here. Find the lowest common denominator, the least common denominator for the fractions. And that way you can add them together. Okay, so the lowest common denominator is often the least common multiple. So if you look back at your notes, for these right here, right, the least common multiple, smallest common multiple that is divisible by both numbers. So that's how we add fractions together, is we have to find a common denominator, which is a common multiple between both of those fractions. So in this case, if you think of multiples of 2, it's 2, 4, 6, 8, 10, and multiples of 4s, 4, 8, 12, right? So our least common multiple in this case is going to be 4. So I want to change 1/2 p to actually 2/4 p. So I'm going to rewrite that now as 2/4 p plus 3/4 p. And now I have a common denominator, and I can add these fractions together, and the bar models will work out as well. So let's represent 2/4 p over here. So here's my bar model. That represents all of p, and I'm dividing that into 4 sections. Okay. 2/4 would be shading in 2 of those sections, 2 of the 1/4. That gives me 2/4 p. And I'm going to be adding to that 3/4 p. So now I'm shading in 3 of these fourths. 1, 2, 3. So that represents my 3/4. And now when I add those together, I want to make my new bar model with the same common denominator of 4. So there is p split into 4ths, and let's draw in 2/4 with the blue and 3/4 with the green. So we have 1/4, 2/4, and then right? We ran out of space. So we have to include another fourth, right? This represents 1/4 p. And so we're going to shade that in green. So 4/4, which represented a whole, right? This was 1p. And then this little part here is that extra 1/4 p that we had left over, because when we combined our bar model, it became larger than just 4/4, right? This is 1/4, 2/4, 3/4, 4/4, which is 1, and then another fourth. So when we add those two terms together, we can say it's 1 and 1/4 p. And if you're sticking to color coding, we really should say that that is p there. Another way to represent that is to leave it as an improper fraction and say it's 5/4 p. Now, I know there are some of you saying that, why do I have to make a bar model to represent this? And really, what I'm doing here is, because you're in 7th grade math, you're not in algebra quite yet. I'm trying to give you different ways to represent variables, so that you have this kind of toolbox when you get confused. So if you need to think of a variable with a bar model and add bar models together, that is one way to do it. If you are kind of thinking more algebraically and less conceptually, you don't have to think of the bar models, and you can think of the more procedure, which is just adding these fractions together. So 2/4 plus 3/4 is 5/4 p. So if the bar model confuses you, you don't have to do that when you're doing the practice, okay? Kind of similar to like the number lines when you're adding and subtracting integers. You don't have to always use the number lines. But for this one, I'm going to give you 4 problems over here for you to do, and I want you to use the bar model for those 4 problems. When you move on to the practice and you move on to the test, you don't need to use the bar models if they don't help you, okay? If they do help you, by all means, okay? But the amount of work that I need to see on the practice is really just that right there, okay? You don't really need to show any bar models, but for here, this kind of check-in that you show me after your notes, so that I know you understand, you're going to use the bar models for those. And the other problems that I want you to do on the left side, I'll read them out to you. It's 0.2y plus 0.6y and 0.8p plus 0.5p. And number 3 is 1x plus 3/4 x. And lastly, 1/4 x plus 2/3 x. One thing you want to be careful of is if they give you a variable like y or p or x, you answer with the same variable. So a lot of times in algebra, people get so used to using x, y, and z that even if the variable is p, they often give their final answer with an x. You can't do that because you don't know what x equals and you're trying to solve for p. So you will get the problem wrong in that case. Here you're just trying to simplify the expression by adding. And again, use bar models for these 4. So you might want to spread them out a little bit more than I did on this page. And then on the practice from the textbook, you can do them either way.